Hello again. This is Math 1218 coming to you from the College Edu page, and the title of this lecture is The Key to the High Stakes Assessment 3 on Consumer Mathematics for Spring of 23. As always, please be attentive while watching this video. Some of these questions may find themselves being asked on the comprehensive final as well. Number one. In 2007, M&M sales were $238.4 million, which was 13.2% of the total chocolate candy sales. What was the total amount spent on chocolate candy in 2007? Well, the $238.4 million represents 13.2% of the total spent. So to find the base, we're going to take 238.4 and divide it by 0.132. And we get that the total amount spent on chocolate candy in 2007 was $1,806 million. Number two, you were to calculate the federal income tax owed for a taxable income of $56,400, and you were to use an appropriate table, and this is the table that I gave you in the grace notes. So you take 56,400, you subtract the number here, which is 39,475. You found that there was 16,925 over. You take this number times the 22% to get 3723.5, and you add the 4543 to it, and your answer to the problem is 8266.5. Number three, Palma wants to establish a fund for her granddaughter's college education. What lump sum must she deposit in an account that pays an annual interest rate of 6% compounded monthly if she wants to have $10,000 in 10 years? Well, it's compounding monthly, so the N is going to be 12 times 10. R is going to be 6%, that's 0.06, but I divide by 12, I get 1.05. And so we want to find what P is. We want to have $10,000, so A is 10,000. We have these numbers, and that is 120. So I do the calculation and divide to solve for P. So P is 10,000 over 1.005 whole raised to the 120 power, and that gives you 5,496.33 rounded off. Number four, you have agreed to pay off an $8,000 car loan with 24 monthly payments of $400 each. Use a simple interest formula to determine the interest rate you are being charged, and this is an annual percentage rate because it didn't talk about that, and again, it's a simple interest formula. So the interest that you pay, or the total amount you pay, I suppose, is 400 times 24, which is 9,600, which is 1,600 more. So the interest that you're paying is the 1,600. The interest is equal to the principal times rate times time. So it's the interest was 1,600. That was the principal, the rate times 2, you solve for R, and you get R is 10%. Number five, you were to calculate the finance charge for the following credit card for August, which had 31 days, using the average daily balance amount. July's balance coming in was $275, and the annual interest rate is 18%. Okay. So what happens then is we make note of the payment of the incoming balance, the payment that we make, and the additional charges, and so we tally up the days. So the balance was $275 for these 5 days. It was $200 for these 6 days. It was $315 for these 7 days. It was $335 for these 5 days, and it was $351 for these 8 days. So I multiply the number of days times those to get these balances, and my average daily balance is, I add up those numbers and I divide by 31, and I get the average daily balance was 298.81. And so I take that as my principal. The rate is 18, but it's this fraction of the year. It is 31 over 365, so your answer should have been $4.57. Number 6, Bernie purchased a riding lawnmower for $1,320. The store offered him a 3-year add-on loan at an annual rate of 8.25%. How much interest will he pay, and what are his monthly payments? Well, the interest is going to be 3 years. That was the annual interest rate. That was the principal. So it is this amount. So you take the principal. So for the add-on loan, you just say principal plus interest divided by n. You had two numbers you really wanted to give me for an answer. How much interest will he pay? He pays 326.70. But then you have to calculate his monthly payment using this formula. You plug things in and you get it's 45.75. So there are two answers that were expected to get full credit. Number 7, assume you're saving $350 a month in a retirement annuity and you have an interest rate of 4.2%. That's an annual interest rate. Assume your income taxes for the life of the annuity are 25%, but after you retire, they drop to 18%. How much more do you earn in 30 years in a tax-deferred account than in a non-tax-deferred one? Well, in the tax-deferred plan, you don't pay any taxes till the end of the problem. And so you're putting in $350, and all $350 gets deposited. This is the equation, and you find out that the amount at the end of the term, the 360 months, is going to be $251,767.45. Now, in this account, you paid $350 in 360 times, so the amount of interest was $125, and this is 767.45. So you see, when you withdraw this account, you have to pay the taxes on this amount, the total amount, but now it has dropped to 18%, not 25%, and so what you have is you will get to keep $206,449.31. Now, if it was not deferred, what happens is you have to pay taxes at the beginning on this $355. So instead of putting $350 in, you're really putting $262.50. But your taxes are paid on this part of it. So what you do is you use this number times this, and this ratio is the same, but you see the downstroke is different. It's 262 instead of 350. So the amount that you have at the end is 188,825.59. Now your interest is the difference between that and the total amount that you put in, which is this 262.50 times 360, and so this is the interest that you have. But now you've already paid tax on the thing, so the only thing you're doing is paying tax on the interest. So you will get your interest, but then you have to pay tax on this amount, and so you pay tax on that amount, and you do the calculation. You get 171.84698. So if you take the difference between this plan and this plan, you conclude that the tax-deferred plan earned $34,602.33 more than the non-deferred plan, and that is the answer to the problem. Number 8, you're making monthly payments of $300 into an ordinary annuity that pays 9% interest. How long will it take to accumulate $10,000? Well, you're getting 9%, but you're doing this monthly, so it's 9% over 12, so it is 0.0075. So this is 0.0075 whole to the n minus 1 all over that number again, times your payment, which was 300, and you want to solve for this to get 10,000. Now you have to solve for the n. You have to use logarithms, but when you use the logarithms, you will conclude that if you do this for 30 months, you will have reached the $10,000 mark. And 30 months is the same thing as 2.5 years. Number 9, you were to complete the first 2 lines of an amortization schedule for a 20-year, $100,000 mortgage if the annual interest rate was 8%. Here are the formulas that you're using. Your monthly payment is going to be $836.45. That's what happens here. They always get their interest, so the interest is always on the unpaid balance. So the first time it's on the 100,000, but then as you go forward, what happens is that the amount applied to the principal increases. So these are the numbers that you should have had on your sheet. Number 10, you were to find the monthly payment necessary to pay off a 4-year amortized loan of $5,000 if the annual interest rate was 10%. Well, this is a monthly payment, so you divide the 10% by 12, and we're doing this over 4 years, so that's 48 months. And so here is the formula, and so we're going to solve for R. And when you solve for R, you should have gotten 126.82. Number 11, Ann took out an $1,800 add-on loan for a professional quality color printer, which she will repay with 12 payments of $163. Now what we wanted to do was use an appropriate table, and I gave you this table. This was the only appropriate table I gave you to find her APR to the nearest percent. So let's find out how much she paid in finance charges then. So it is, she made 12 payments of 163 on a principal that was really $1,800. So that means her finance charge was $156. We take the finance charge divided by the amount borrowed, 156 over 1,800 times 100, and that is the 8.67. And we look in the table trying to find the closest thing to that. Now we were doing 12 payments, so we were in this row with 12 payments, and we were 867, so we were very close to 16%. Finally, number 12, we're use an appropriate formula to estimate the annual percentage rate on a loan that has an annual interest rate of 8%, and it will be repaid in 20 months. And again, I told you to assume this is an add-on interest. Well, our formula that we have is APR is approximately equal to 2NR over N plus 1. Now, N is 20 months, so we plug in 20 for that. R is 8%, and 2 is 2. You do the arithmetic, and you get 15.2%. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself because self-care is important. And now more than ever, take care of each other because we're all in this together. I look forward to seeing you guys in class soon. Until that time, God bless you all. Take care.